Hello student. So we are at the last lecture of module 11 on disposal of solid waste, and in this lecture we will have some example for design of landfill. This design is not the complete design of landfill, but some of the numericals which will be helpful for maybe for preparation of your GATE exam or maybe engineering services. I think these only two examples. I am some two numericals will try here, and also there is one of the very important topic, especially for India after the Swachh Bharat mission, that how best we can biomine the old dump sites, because there are a lot of old dump sites was available, and because of Swachh Bharat mission, the many cities like Indore and many other cities, they are trying to clean the old dump sites, because getting space also is very difficult, special place to install the sanitary landfill. So, why not the same dump site could be useful for to start the new landfill site or new sanitary landfill site. Otherwise, I think some more maybe composting plants could be possible to use in the same location, because many hundreds of acres of area was used by the old dump sites. So, first we will go for numericals followed by biomining. So, the first example we will see here, the question is that estimate the required landfill area for the community with a population of 31,000, assuming the following data or conditions. The solid waste generation is given 2.9 kg per capita per day, per capita means per person per day, and compacted specific weight of solid waste means a density is given 475 kg per meter cube, and average depth of compacted solid waste is given 6 meter. So, we have to calculate how much area will be required. Okay. Maybe the area we can calculate in a year, or maybe it is good to calculate in a year, because it again depend upon the because that data is not given, how much year or for how many years this landfill site could be useful. So, the solution will start. First, we will calculate the daily solid waste generation rate in a tons per day. So, we know we have the population 31,000, and per capita generation per day was knowing 2.9 kg per capita per day. So, to convert that kg to ton, we divided by 1000, and finally, the values came 89.9 tons per day generation rate. Now, we will go for required area for that. So, obviously, area we can calculate by the volume available divided by specific weight or compacted specific weight, and that also the specific weight is given in kg per meter cube, and the generation rate we found 89.9 tons per day. We convert that in the kg by multiplying 1000, and we calculated the how much volume will be required, 190 meter cube per day. So, this is the weight, how much is the weight divided by density. So, now we will calculate the how much area will be required. So, we know the volume, and we know the depth. So, we will divide by the depth of and this depth is given in the question. The average depth is 6 meter, and this we are converting in the hectare. Okay. So, hectare if you divide by 10,000, the volume will come up, the area will come up in hectare per year, and per year we multiplied by 365 days in a year, and now the area is coming 1.15 hectare per year. This is the answer, that in a year this much area means 1.15 hectare will be required for disposal of waste from 31,000 population. So, and I think few comments, because this much area will required for the disposal, and also will be required 20 to 40% area as in buffer zone for office, some service building, access road, some more facility will be required for the landfill area. So, 20 to 40% area will be required in more. Okay. So, this is what the answer. Okay. You need not to write this, but just for if suppose the question will ask like how much total area will be required. So, you can put it the 20 to 40% of this area and sum up with 1.15 hectare will come up with the this much total area will be required along with the waste disposal facility, also some agent buffer zone for other facilities. Now, the next example is a determination of density of compacted solid waste without and with waste diversion. So, the question is that determine the specific weight in a well compacted landfill for solid waste with the characteristic is given in the table, and also the question is asked to calculate the specific weight, like in the previous question was to calculate the area. Now, here is we have to calculate the specific weight and also determine the impact of resource recovery program. And what is the resource recovery program? Is saying that 50% of the paper and 80% of glass and tin cans are recovered. So, whatever the specific weight we will get it for the without any waste diversion program will reduce the specific weight of 50% of paper and 80% of glass and tin, and these are the datas are given. So, datas are given in the organic fraction, inorganic fraction. So, you see here the up to wood, this is the organic one, and remaining are the inorganic one. So, here the weight is given in the percentage is a total is 100% and the specific weight is given, okay, for the each waste. Okay, we have to calculate the total specific weight and also the compaction fraction is given. So, after compaction how much will be the specific weight will be remain after compaction, because we have to calculate the well compacted landfill for solid waste, that specific weight we have to calculate. So, the first we will take the weight of the waste. So, the we will first calculate the weight of the individual solid waste component. So, here what I did, I multiplied by 10 of each percentage and the total quantity I assume that 1000. Maybe you can go for 10,000 also, 1 lakh or 10 lakhs also you can do, or you can put it 1 also. So, this is what the total weight, and based on that we calculate the volume, and after that compaction factor we multiplied by that. So, we will see one by one, and finally, we calculate the compacted volume. So, the volume we calculate volume as discarded. So, that we calculate weight divided by specific weight. So, we are knowing the specific weight of each weight, we here we kept by multiplied by 10 and we calculate. Likewise, for food waste the 90 kg was the total weight and specific weight was 291 kg per meter cube. Finally, we got the volume, that is 0.31 meter cube, and then the same volume we multiplied by volume as discarded with the compaction factor. So, compaction factor was 0.33 for food waste, you see here. So, 0.33 was the compaction factor. So, whatever the compacted whatever the volume we got 0.31 multiplied by compaction factor of 0.33 for food waste. So, we got the compacted volume 0.102 meter cube. Now, this is for the one waste. Now, you see here likewise we calculate for all different of waste, and finally, we got the compacted volume of 1.8 meter cube summing up of all waste. So, total weight is 1000 and compacted volume is 0.1 meter cube. Now, we will calculate the specific weight. So, compacted specific weight obviously that is weight divided by the whatever compacted volume. So, weight was 1000, volume was 1.8 meter cube. So, the compacted specific weight got 550 kg per meter cube. This is your answer for the first question. So, how much is the specific weight of well compacted waste? So, that answer is 550 kg per meter cube. Now, the another waste diversion program was given and told here the 50% paper and 80% of glass and tin can be recovered. So, that first we will calculate the weight remaining. So, the total weight was 1000 and now the total weight of paper was 340 and glass was 80 and for tin was 60, and likewise we multiplied by each value and finally we got the volume. So, similar way remaining weight is 780. Now, the earlier the weight was 1000 and after 50% of paper recovered, 80% of glass and tin recovered will be remain with 718 kg. Okay. And now we calculate the weight remaining. So, similar way we had the total weight was 1.8 meter cube. We reduce volume from the paper, glass and tin, and finally we got 1.3 meter cube of volume. Now, we can calculate the specific weight again of remaining waste. So, again the specific weight now we will calculate here by 718 divided by 1.3. So, this whatever the answer will come up here, this will be the your specific weight now. Finally, after recovery of paper, glass and tin. Okay. This is the final answer. Okay. So, I think these are very simple examples to calculate the area and to also calculate the specific weight of the waste. So, these are the very simple solutions. By that way we can calculate the how much area will be required, how much the specific weight will come up into the or compacted waste. If you have the proper data, we can calculate that. Later on then we can design the leachate collection system. For that actually problem is that in India there is no proper manual for the designing of this one. But I think if you really want to learn that one for designing that, please read the or download the solid waste manual 2016. This is available online in the website, easily can be downloadable, and you can see that there are some equations are given. By that way you can design that. Now, we will go for biomining or legacy waste. So, first we have to see that the present status of legacy in waste and its impact on the environment. So, there are two major challenges of solid waste management in our cities or town. The first is managing the continuous flow of solid waste on a daily basis. So, this is the very important point that, so suppose if you want to change the location also, so before changing the location you need to well aware about the another location, because everyday waste is need to be collected and disposed of properly, and dealing with the legacy of neglect which has resulting in the garbage heap having been built up in the dump site they were, that means waste processing or landfilling. So, this legacy waste is become a huge issue, and normally the site of landfill were originally located outside the city, but the city have expanded and dump site are now almost in the city. So, I think wherever your city is there in India, try to visit the disposal site. So, the earlier, because when any particular city they try to finalize the location. So, the idea was very simple idea was location just outside of the city, some low lying area, so that we can get more volume and easy to transport, or the collection cost should be as low as possible. That was the thought, but what has happened, because the population has been increased in the city, you know that lot of rural people are there trying to come to the city area, and even nearby these kind of dump sites, lot of people are working, I think for collection of recyclable matter. So, one by one, I think in the small example if I will give, in Guwahati itself there are 500 different families are residing nearby dump sites. So, once they will be leave it in for 10 years, 15 years, after that lot of population also will be nearby. So, likewise, and the cities are extending now. So, now many cities, like if you visit Trichy in Tamil Nadu, their dump site is almost is a center of the city. Now because the cities has been extended so far, but now I think the problem is that the dump site is almost in the middle of the city. Now that waste become a huge issue, because the and you know that see, already in the previous lectures I told that the monitoring after closing of the landfill for 20 to 25 years, again the monitoring is required for 15 years and should not be allow any kind of construction, any kind of habitation in that area. From starting is almost 40 years you can't live nearby those areas or not habitable those areas. Now is a very big issue for the local authority or local corporation. So, how best they can recover that particular location, or that legacy waste they can dispose in some other area. Like I have some data about like Delhi, open dumps at Ghazipur is I think maximum height is 69 meter, Okhla 55 meter, and Bhalaswa 56 meter. All are much higher than the permissible height limit of 20 meter. And you know that they already have the area of 10,000 hectares or urban land. See, in Delhi kind of city where this waste took almost 10,000 hectares waste area is a very big issue for that particular city. And also the lot of problems also still coming in those particular area. If you go to the Okhla, every time the nearby habitations, they will always have the issues about odor issue or even the leachate issue, always they are seeing in the nearby area. And because the landfill site generate greenhouse gases, methane, and which contribute global warming also, and a lot of health issues are coming because of that, by producing leachate which polluting the groundwater also. So, this is what one open dump site you can see here. So, many municipal authority across the country are opting for capping as a solution for the legacy of mixed waste, the capping. So, I think some of the city what they understood by capping, I think they close the entire area and put up the soil onto the filled with the soil onto the top. If you are able to visit Surat, the dump sites, what they did, they the entire area they capped completely and filled with the soil onto top of the waste material. So, if you visit that, you will see that is a purely soil everywhere, but in the bottom waste is still available, and obviously the entire degradation won't be possible so early. So, the leachate will always go into the groundwater. So, nearby habitations will always have the problem, not for air pollution, but for groundwater issue will be always there. So, what has been done here, like in our solid waste management rule 2016, the schedule 1 class J has been properly explained how best we can biomine this particular area, or how best we can cap such kind of dump sites. So, what provision has been given in SWM rule? So, the provision is that the Government of India has notified the Solid Waste Management Rule 2016 for proper and effective management of solid waste management, and following provisions had been given, that is in Rule 15, where the duties and responsibility of local authority or village panchayat of census town and urban agglomerations. The authorities and panchayat shall investigate and analyze all open dump sites and existing operational dump sites for their potential of biomining and bioremediation, and wheresoever feasible take necessary action to biomine and bioremediate the site. That was the one special duty are given to the local authority. This local authority could be corporations, ULB, or even the village panchayats which coming on to the adjacent census towns. So, in absence of potential of biominding, bioremediation of dump site, it shall be scientifically capped as per the landfill capping norms to prevent further damage to the environment. So, it has been explained that if suppose the waste do not have potential of biominding, bioremediation, so need to have proper scientific capping, not like just filled with the soil on to top of the waste material. But I believe that for in India the mixed waste will have the lot of the easily biomining or bioremediation could be possible. And also had been asked that the bylaw shall apply to every urban local bodies, overgrowth in the urban agglomeration, cantonment board, panchayat, this and also these kind of biomining could be come up through the bylaws. So, easy to work on to the biomining projects. So, what we understand by bioremediation or biomining of old dump sites? It refers to the excavation of old dumped waste. The first it refer, when you say the bioremediation or biomining, especially this biomining word, what it refers that excavation of old dump site waste, make windrow of legacy waste, windrow that you please remember that when composting, when you talked about the windrow composting. So, make the windrow, similar kind of windrow. Thereafter stabilization of the waste through bioremediation. So, they propose that through bioremediation means some kind of culture, bacterial culture you add it into the waste, so that whatever is the degradable matter will get degraded as early as possible. And or this exposure of all waste to air, either air along with the use of vermicomposting bioculture, and then followed by screening of stabilized waste to recover 11 valuable resources. That also has been explained, like organic fines, bricks. These organic fines, I think this is what we called as a city compost, but I think saying compost is not proper word, but I think earlier we used to talk about that was a compost, but is a proper word is a organic fines, brick, stones, plastic, metal, cloth and other, and followed by sustainable management through recycling and co-processing. So, this is the complete flow chart, you can see that biomining. So, please understand properly here. So, when you say the biomining, first is the stabilizing waste, means that is a windrow, go for windrow, and to provide proper aeration and try to add some bioculture for the degradation process. Once the degradation will get over or the material will get dry completely under the windrow, we will go for screening of waste. So, screening of waste in the different sizes. So, size more than 150 mm goes to the, this will contain like bricks, coconut shell, footwear, clothes. Likewise, the different size will have the different kind of compositions, like 4 to mm size, this could be a mostly a bio earth, or we were talking about organic fines. So, could be useful for the farmers or can be useful for the soil conditioner. Remaining that most of the materials could be possible to use it for RDF process or could be useful for the recycling process. Maybe some of the materials could be useful for the road construction purpose also could be possible, some particular size. So, the processing equipments for processing of legacy waste, the major equipment that will come in the use would fall under the following heads of processing, like excavation. This is the few important processes like excavation, shredding, screening, air classification or ferrous separation. So, for screening you will be required trommel. Remember that this trommel segregation I talked in the composting process. So, centralized composting facility is already have the trommel facility for waste screening, or otherwise vibrating screen also can be possible, or disc screen. This screening also we discuss into the recycling lectures, and some handling equipments like front end loader, conveyor facility or forklift, these kind of again equipments will be required. Now, the process of bioremediation and biomining, the first step will be the schematic representation of biomining through excavator by making windrows. So, how to make the windrow? This is also has been explained properly under our solid waste manual. The first go for excavation to dig 2 to 2.5 meter deep trenches and go for excavation and hand pick the large object or the big particle size, or maybe some recyclable matters could be hand picked, and then make the windrow from the remaining waste. So, try to get whatever the hand pick could be possible, that recyclable matter or large material which could be utilized for the some other purposes. Otherwise, you go for windrow remaining waste, and when you go for windrow, add the 5% of cow dung, mix in water and spray onto the waste. That could be your bioculture. So, rather than purchasing commercially available biocultures, you can simply 5% cow dung you mix into the water, and that you can put it, or the spray you can put it onto the that particular windrow. Turn the windrow by 2 to 3 days, and after 20 days do screening. Maybe 20 days, 30 days are well enough for the degradation of whatever organic fractions available there. So, about the closure and rehabilitation of old dumps, solid waste dump which have reached their full capacity, or those which will not receive additional waste after setting up a new or properly designed landfill, should be closed and rehabilitated by examining the following options. So, could be by reduction of waste by biomining, waste processing followed by placement of residues in new landfill, capping with solid waste cover or solid waste cover enhanced with geomembrane to enable collection and flaring utilization of green gases, or another capping with additional measures could be possible. So, I think important is that excavations of dump sites. So, this is the way we can excavate 2 to 2.5 meter depth. So, excavator to dig 2 to 2.5 meter deep trenches, then hand pick the objects, like you can see here the hand picking. So, try to call the, even you can call, in this case lot of rack pickers are there available in the most of the landfills. Ask them to hand pick the material, but I think use the proper gloves, even the on mouth also try to use. Your cloth also should be somewhat good, should not be have any problem while hand picking. So, hand picking could be that rock, coconut shells, large piece of cloths, large plastic bags. Then we will go for windrow. So, this is what I think windrow, this similar kind of composting windrow, but try to go for a small as possible, so that you can turn very easily. So, windrow consists of placing the mixture raw material in long narrow piles called windrows, almost all of them involve forming the waste into a long low heaps of about 1 meter height called windrow to get maximum surface area to volume. Usually 3 to 4 turnings of legacy waste necessary to stabilize it, and use a excavator to dig deep trenches downward from the top of legacy waste. And now after 20 to 30 days go for screening. So, the first you feed it into the first trommel. So, this facility you remember that the similar kind of pictures I showed it into the centralized composting facility. So, and I especially believe that now, because in the old dump sites already those composting facilities are available. Why not utilize the same facility, the centralized trommel based composting facility for screening of the legacy waste. And this is another trommel, and finally, the last trommel, that 4 to 6 mm. So, what could be the use of screened fraction? When planning for bioremediation, it is important at the same time to identify whether the screen fractions will go. So, look for nearest industry using solid fuel. See, again you remember that when you are planning for biomining, so is not only the excavation, hand picking or windrow, also this point is important, that what you will do with the screened material, because that is also need to be know. Otherwise, what will happen, you screened it and again it will remain in the same location. So, first could be possible that try to find out the nearby industries which can be used that this particular material for the as an fuel. Maybe this dry material, the paper, plastic, and that is highly combustible matter, can be used as an fuel. Look at the nearest bitumen hot mix plant, also specific plastic roads in the road trenches to ensure uptake of the thin film plastic fraction. So, is also possible. This kind of material can be used for bitumen hot mix plants, or specific plastic road also can be come up onto these. Start a dialogue with all kabadiwalas within the local bodies to see who will be willing to pick up or accept which item. So, this is also very important point. I try to put it here, because there are a lot of kabadiwalas are there. This is a informal, purely informal sector. So, this is also possible that you call all the kabadiwalas and ask them, okay, this is all segregated material we have available with us. If they are able to get it that, so that is also good. That is beneficial for us also as in local authority, also beneficial to the kabadiwalas. They can put it that particular fraction for again for either recycling, or they can sell it to the other industries. Plan for offsite aggregation space for different fractions and type of waste that will be result from the screening. So, along with that, I think you already be in contact with the local people, or which can be utilized this kind of material, but also plan for the offsite aggregation space, where we can put all these fractions in different locations. Identify aggregation and storage shed for use by waste picker group or kabadiwalas, because see, when any kabadiwala will also accept that, for them also they can again segregate the material, they can again screen, and they by putting lot of manpower, because they will have lot of rack pickers are working with them. So, for them I think is good. I think if you can put one particular shed, some storage facility, so any kabadiwala can come and can collect the waste material. Identify transporter who can transport the different fraction on their return trip. This is also one important point, because in kabadiwala, if you can provide them one particular transport, that is also beneficial. For the bio earth or good earth fine fractions, test periodically for heavy metal. So, this is the important one. So, whatever I was talking about the organic fraction, that 4 to 6 mm, that tests periodically for heavy metals. Why? Because suppose if you do not find much heavy metal into that, try to find some farmers which will be willing to accept it. But I personally believe that farmers won't that won't show that kind of willingness, but at least for horticulture purpose you can use such kind of material, but check for heavy metals, but it will have the lot of metal percentage into that. For process management like space management has to be there, because all these facility like windrow facility and segregation facility, you will require the proper space, and along with that the other operations like earth movers operations, you will be required space, and every dump site poses case by case challenge, but there is no above ground dump that cannot be successfully bioremediated by biomined. And for along with the space also one important factor is a leachate management. Now you will say that, sir, from where this leachate has come up? See, this is the old dump sites, and in rainy season lot of water will be available into the dump site, and this the water will be not only in the bottom, but in the top area also the water will be like. So, you can see that most high heaps of legacy waste are waterlogged with leachate even near the topmost layer and all the way to the bottom. This is, I put it like dhokla, yeah, simple way, where from the top to bottom say waterlogged. This is not just from rainwater entering the heap, but it is produced by airless rotting within the entire waste heap, because the degradation will be always there. So, because of that the water will also produce. So, when legacy waste heaps are opened up, some leachate almost will come out, and this is not produced by the formation of windrow or cones, which in fact help to dry out the waste by aerated decomposition. So, also be ready, some drains you provide for such kind of leachate, and when you are going for the windrow facility, and there is a chances of that leachate will be come out. So, wherever I think windrow you are planning, plan for proper drainage for collection of this leachate, and this leachate management, the channels must be created to lead the this particular leachate from windrow facility, and what we will do with that leachate? Again you recirculate into the windrow top of the waste material. So, that the that can be also used as an bioculture, or you can mix with the bioculture and again you can put it into the windrow facility. Or leachate can also be treated in collection pond by underwater composting, also can be treated, but I think this will be somewhat costly process. And bioculture that has been proved successfully at other location can be sprinkled onto the leachate pool. Also the intermittent aeration also will be beneficial, and aeration is necessary for the added microbes to their work for digesting the organic matter. And how we can find that, how is it beneficial? By addition of bioculture or addition of aeration, by changing the color from dark to light, if you can find, you will come to know that the leachate is getting treated. Now, fire control and safety, this is also one important understanding. Large dump sites are could have hidden fires, because it contains methane, and many times when you excavate the dump site, you will find some flames are coming out from the bottom. Okay. So, it is difficult to begin bioremediation work on a smoking dumps. So, sometimes digging into a dump awaken hidden fire. So, that fire control is important. By adding water increases the generation of both methane and leachate. So, could be possible you add water to that, but again it will increase the methane production, leachate problem will come up. But I think is good, rather than water add the soil. So, the soil cover to smoother the flame adds more material to heap that one is trying to bring down. So, addition of soil is much beneficial. Now, schematic representation of screen components and its sustainable disposable. So, this is the again simple explanation, like the segregated material or screen material component and what could be the sustainable disposable for that. Like for final organic compostable waste can go for landscaping, farming, can be used as soil conditioner or fill it back to the dump site. The daily cover you can make it out of that. Light and medium fraction can be after separation of waste by screen shading as per the requirement industry need, compact it to the dump site. So, this light material like plastic, textiles, many industries can be utilized very easily, like heavy fractions like C&D waste, construction demolition waste, stone, glass can be recyclable or also can in some industries can be utilized, and remaining that inert material again can go for new landfill sites. So, what could be the use of recovered space? I think once you clean the entire area, also has to see that, because that will be a valuable space. Now, many locations are the middle of the city. So, what we will do with that? So, is a dump is surrounded within a growing city and is continuously used for waste management is unsuitable. So, that we can plan for recovering that particular space, but the clear dumps, these clear dumps are not permitted for habitation for at least 15 years. This is based on the SWM rule schedule 1 H2, especially is writing like this: clear dumps are not permitted for habitation for at least 15 years. Okay, there should not, whether is a very close to the city, whether is a center of the city, but should not be used for any habitations. This is because of unhealthy leachate below the sites, formation of flammable offensive landfill gases from waste pockets. See, because we digged up to 2 to 2.5 meter, because we thought of, because the maximum depth in the earlier days goes to like this, but still because lot of leachate has been added into the earth, is already leachate is there, and because of that lot of waste pockets, the some polluted gas will come up, and these kind of issues will be always there. So, what could be the permissible options? What could do in that particular site for at least for 15 years? Can have some park or gardens or even parking lots, you can make it that particular area, okay. And is good to grow something in that particular area, maybe park is the best idea or garden you can make it, but I think and for initial period also do not allow the local people in that garden, for at least wait for 5 years or in time to time collect the gas in that particular area, gas samples try to collect it, and also check the groundwater time to time. So, that you will see that by biomining that particular location, how best you recovered the groundwater quality or recovered the local atmospheric conditions. So, if you see the two cases, I think I come up with two cases successfully where biomining have been done. So, the first is the Indore. I think this is the one of the cleanest city in India, or is the best clean city. So, they had a 100-acre dump sites in Devguradiya, was home for 15 lakhs metric ton, 15 lakhs metric ton. okay, of legacy waste, and that accumulated over decades. So, when they started the biomining, their idea was to get the recycling, reusable polythene was used in the road construction, soil record was used in the filling the grounds, and construction demolition waste recovered and sent to the produce building material. So, that material had been utilized further, and Indore treat 15 lakhs metric tons of waste in total 3 years period. It is a similar kind of facility, biomining facility. Now, you see here, this was the old time, see here, this was the old dump sites. Now, you see here the same locations, this is become like this. Now, nobody can say that this was the old dump sites. Now, these particular locations you can see here in this photograph, you can see the lot of habitations very close to the dump sites. And now, if you ask anyone, anybody will be wants to have a habitation in this area, and need to see that there should not be any habitation in this particular area. So, another case of Kumbakonam in Tamil Nadu, this is also very, I think, one of the best or successful story of biomining of legacy waste. The municipality reclaimed around 12 acre or prime land that was laid waste after being turned into a garbage dump yard over the years. The status of Kumbakonam dump site out of 1,31,250 meter cube, more than 1000 meter cube has been processed and successfully disposed, and 7.5 acre dump sites with garbage more than 5 acres has been reclaimed. The project cost was around 7 crores that was required, and the plan achieved 0% rejects, which means none of the aggregates are considered as rejects and dumped back into the sanitary landfill. This is also a very important point. No rejects has been remain. So, everything has been utilized for some other valuable purposes. So, if you see the photograph, so this was the old one, old sites. Now, if you see here, how clear area this become. There is also a lot of habitations nearby area. So, this is also very important now, the legacy waste management, and the facility I see the cost also, one of the projects I told about 7 crores. This also won't be required much, because many cities have the trommel facility for as an composting facility. So, why not the same facility can be utilized for biomining purposes. So, but still there are number of cities that remain with the legacy waste, and I think everyone has to be look, but see any city can start the biomining, but they should have alternate site is available, and alternate site not like similar kind of dump sites. Then what is the benefit of biomining of the old landfill? So, first you plan or construct the sanitary landfill, start the disposal in the new landfill area, close this particular site, close means the fresh waste should not be added into this old landfill, then wait for few months, and then you start the biomining of this particular area. So, likewise we can do, and also remember that once you take it out entire material, try to fill with the soil, again you do the capping of that particular site, which you saw in the two photographs, Indore and Kumbakonam. What they did, once they collected entire material from that, after that they filled with the soil. Soil means is a one kind of capping they did in the entire location, so that polluted gases should not be come out, but they can't work for the leachate now, and slowly that leachate the concentration of leachate into the ground, that will also be reduced with time. So, and based on the rule suggestion 15 years you can't operate, later on you can have any kind of habitation into that, but still I believe that habitation should not be there. Some other facilities could be for purpose that can be utilizable, or otherwise if you can reclaim the same site and the site is still far away from the city or is a outskirt of the city, you can again work for the sanitary landfill in the same location. This is also possible, because many cities do not have the alternate locations for them. So, go for biomining, or otherwise if you do not have any alternate location, parallelly you work for biomining also, and parallelly sanitary landfill also you operate in the similar facility, but the space requirement will be large in that case. So, I think here we are finishing our disposal module, and here actually we finish all the 6 functional elements of the syllabus, but again I was thinking to add a few more modules here, like specially we did not much talk about the special waste like construction demolition waste, and also although the e-waste or biomedical waste is a separate lectures or separate course to study, because their management treatment entirely different ways is possible, but still that e-waste and biomedical waste, construction demolition waste is still available in the city area. So, I thought of to have one particular module onto that, and finally, we will go for the rules and regulation and integrated waste management facility, that we will discuss in the followed lectures and modules. So, thank you.